I'm about to kickstart a new IoT project, but how do I pick the right hardware to start? That's the topic of today's video. Hi, welcome to Cafe Dev. This month, I'm creating a new IoT object from scratch for my grandmother. If you don't know this series, I encourage you to watch the first video. So I'm creating a new object that will be autonomously connected to the internet so I can send picture to my grandmother. So let's back to the hardware requirements I've created on the first video. As you can see, I have a few hardware requirements. I need a screen to display some picture or even some drawings. I need some buttons for quick answer, so I know when my grandmother actually saw the picture. An LED or buzzer or anything that can alert her that a new picture is waiting for her, and a way to send and receive data autonomously without any internet or Wi-Fi connection. As I said in the previous video, my grandmother doesn't have any internet connection at home, so this object needs to be fully autonomous. So let's start with the hardware requirements. When we speak about IoT devices, we mainly think about boards like the Arduino board or the Raspberry Pi, but in fact we need to widen what we think about the IoT devices and the spectrum of the IoT devices. Of course, we have very small appliances like the Arduino, or here I have a sample of an ESP32 microcontroller, and obviously a Raspberry Pi. But in fact, we can consider that even phones or grown-up PCs can be part of a IoT solution and could be viewed as an IoT hardware. So here I have took my 4 different criteria to pick my IoT hardware for this project, and we will compare these 3 different categories of devices to see what fits the bill. So first, a screen. Yeah, I need a screen, maybe small, not too big, to display the picture to my grandmother. So with an Arduino or Raspberry Pi, obviously you will have a screen if you want, but you will need to add it on top of the device itself. When you use a phone, it may seem counterintuitive to select a phone to kickstart an IoT project, but let's do the math and see where it goes. And obviously, a phone has a great screen. And at the end of the spectrum, I have here 2 different devices, but it's the same kind. It's 2 fully fledged PC running Windows 10. And we have a Nuke Intel, so it's a small PC here. And we also have an Intel stick, which is quite interesting because it's a PC in a very small form factor that can directly attach to a TV through the HDMI port, and we can have access to some power through the USB we have on most of the TVs today. So you can create a connected screen, a connected TV very easily with it kind of devices, and it's less than 100 euros for most of the PC sticks, or around 100 euros. So it's quite cheap compared to a great PC. So for this kind of devices, the screen is really depending on what you put the device on. Then I want some buttons. So quickly, the idea is when my grandmother receives a new picture, she can send a small reply, like picking from 2 or 3 emoji. So I know, or the people from the family know, that my grandmother has actually seen the picture and has appreciated it or not. Looking at buttons, if you look at Arduino or Raspberry Pi, we can do a lot of things, a lot of actuators, but you need to pick your own and to add it to the device. So yes, we can have some, but it's really depending. On a phone, obviously, you have a great screen you can use to display whatever you want. And on the mini PC, the Nuke or the stick, what we do usually is we add a remote control to it, wireless remote control. So I can definitely do it for a few bucks, but the fact is I need to add one more component to my solution. Then I need a way to alert my grandmother that she has received a new message and a new message is waiting for her. So again, going to the Arduino and Raspberry Pi bus, we have plenty of options: LEDs, buzzer, vibration, etc. On a phone, you have everything you want because we usually have a vibration device within your phone. So we can definitely vibrate the phone when a new picture arrives, and we also have a lot of options with the screen, like sending a notification to the device, etc. And on the Nuke stick, most of the time we don't have anything to do that kind of things. So our last criteria, and it's one of the most important for that project, is connectivity. So the idea here is how can we connect these devices to the internet, and with knowing that we have no internet connection at home. Okay. So let's step back a bit and see what kind of connectivity we have in the IoT world. So we have a bunch of different type of connectivities. We obviously have some devices was Wi-Fi. So even the Arduino with the ESP32 has a built-in Wi-Fi chip and a built-in Wi-Fi antenna. But behind this Wi-Fi, we need a broadband connection. We have plenty of this, obviously. But the fact is, in France, and even in France, we have very cheap broadband packages, but it's roughly between this price range. So it's less than 50 euros per month for an unlimited internet connection. But it's still quite in a pricey area because I will just send her a few picture months. Okay. On the other end of the spectrum, we have some radio ways to connect to IoT devices and sensor. There is two big technologies in this area. Sorry, one is LoRa, LoRa, and the other one is Sigfox. And these two technologies, LoRa, you can use it without any license for a small perimeter, but it's really useful when you have to gather data from a lot of sensor in a building, in a factory, for example. And Sigfox has already deployed its own network, and you can just use it. I mean, of course, you will need to pay for it, but it's network you don't have to deploy. So it's really easy to kickstart with Sigfox. So these two kind of radio systems are really interesting. However, they have two caveats to it for this project. First one, LoRa need a LoRa receiver, so I will need to have like an antenna, like on a cellular network for your phone. You need to connect to a cellular antenna which is nearby. However, my grandmothers live a few hundred kilometers apart from me, so I cannot use an antenna on my home to connect with her. I could use Sigfox, but the fact is these networks are very, very limited in terms of bandwidth. I found a video on the Sigfox website which explained this very, very well. And as you can see on the picture, the amount of data we can send to a Sigfox connected devices, and it's roughly the same with LoRa devices. It's only some bytes, 12 bytes per message, and only 140 messages per day. So it's very, very low bandwidth. It's still very useful depending on your IoT scenario. When, as you can see, in a single message, we can pass on a lot of geo coordinates. We can pass on a lot of sensor data. So if what you're doing is simply monitoring the temperature, in different parts of the building, Sigfox or LoRa can be a great fit for getting your device connected to a network. But it's not really useful to send a picture. I will definitely go beyond what this kind of networks can support just by sending only one picture a day. And these limits are for uplink data. So it's data coming from the IoT device to the network. But the other way around, downlink is much more limited. Is 0 to 8 bytes and 4 messages only per day. Again, it's really useful for specific scenarios, like when you want to request a firmware upgrade, or when you want to remotely reboot the device or change some configurations. But it's again very limited to send some pictures, even if I don't need high definition pictures here. So I was looking for another way because at the middle of the spectrum there is a 2G, 3G, 4G networks. An internet subscription in France is about, it's again very cheap compared to a lot of countries, but it's about 15 to 20 euros per month for a 4G subscription with roughly 20 gigabytes of data. So it's very cheap compared to a lot of countries. But again, I will maybe send 20 to 30 picture months, so it's almost €1 per picture sent to my grandmother. And with that price, I rather send a postcard signed and handwritten compared to sending her an electronic message. But this is for traditional 3G subscription. The fact is, there is a lot of virtual operators like Hologram, or like here Things Mobile, which is as a mobile operator I've picked for that project, but offer IoT internet subscription. So the idea is you top up a credit to your accounts and you pay per gigabyte used. So it's a few cents, a few dozen of cents per gigabyte of data, and you have no monthly subscription, which is perfect for my project because I don't know how many pictures I will send her. Maybe during January or during the holidays, summer holidays, I will send her a bunch of pictures, a few pictures a day, and maybe at other times of the year I will send only a few pictures every 3 or 4 days. So it's really perfect for my usage, my current project with the Nanou Box. The other thing which is quite interesting in with these operators is that one IoT subscription, so one SIM card, is available in a lot of different countries with the same SIM card, with the same kind of subscription. And as you can see on the screen, they also have a SIM on chip options. So if you're about to deploy hundred of thousands of devices, you can directly embed the SIM card onto the chip itself, which is very convenient for large scale deployments. But as I've done here, I've only bought one SIM card. So this kind of operators, network operators, can support your project from POC to production, and it's quite cheap to use. So let's back to what kind of devices I can choose. So definitely I will pick up this connectivity for this project with a specific IoT subscription. So I will need a device that will allow me to insert, in a way, a SIM card. Again, the phone is the best for it because it's already have a SIM card reader and everything I need to be able to use this SIM card. For the Nuke or stick PC, I will need to probably buy a router and configure it, Wi-Fi router with 4G, which is an option. But the fact is, again, my grandmother lives quite far from me and I don't want to mess with a problem with the router, and then I cannot debug it remotely. I need to go somewhere to go to our room to reboot the router, etc. So this solution is not really for me for this project. I really need something which is totally independent of everything, and I can totally manage remotely. And with the Arduino, we definitely have some shields that allows people to get 4G connectivity from an Arduino or from Raspberry Pi just by adding the right components. So from what we see from this little comparison, the Intel stick and the Nuke PC could be interesting in some scenarios, specifically if you have signage IoT project. It could be really useful and quite cheap. The phone actually is really great platform to get started with your IoT project, because most of us have a spare phone somewhere, or we can buy a pretty cheap Android device for a few hundred euros. There is a lot of sensor in it. There is a lot of connectivity in it: Wi-Fi, Bluetooth, 4G, LTE, etc. And there is also a lot of sensors we can already use within the device: accelerometer, gyroscope, temperature, light sensor, etc. So it's very interesting to use your phone as a first step for working on your first POC. But for that project, I think I will go to the Arduino path, so I can have a really small device, very cheap to use it. And also, the fact is the Android or iOS phone, etc., is pricier, but it's also more complex to use. And as I said in the first video, I don't think my grandmother is ready even to unlock the screen. So I will need to build my own device. The issue we could have with some Arduino devices is that usually when you see an Arduino with a lot of different components, you see component like this. This is a breadboard, so it's basically a board that allows us to connect to different components in it, and I can definitely not make that present for my grandmother. I want a simple box with nothing's attached, very simple, no wires, and she can just use it and not mess around with that. So we need to find an IoT platform, an Arduino platform that is quite easy to use and quite extensible, so I can get the components I need. So when I do that kind of IoT project, usually I kickstart my project with a board called the AmiChip IoT Dev Kit. So it's a great prototyping device because we had a lot of components in it. We have 2 buttons, we have an LED, we have connectivity with Wi-Fi and Bluetooth, and we have a lot of sensor again. So it's a really useful and easy to use IoT development platform. The fact is, this IoT dev kit doesn't have a 4G connection. I can manage to get 4G connection with the extension ports we have at the bottom of the device. But the fact is, I will need again some devices and some wires, and I don't want it. If you're interested in this IoT dev kit, you can simply buy it on another website for less than 50 euros, including in France with taxes and shipping. So I've done some research about another IoT Arduino compatible platform, and I found out a great platform, which is the M5 Stack platform. The M5 Stack is quite interesting because it's basically it's 2 components. It's a core component, I will show you in a minute, and it's also a lot of modules we can use to extend it. And as you can see, we can have a pretty decent decent looking board without doing any soldering or any wiring, etc. So it's very interesting. So the first thing you need to get is the basic core IoT development kit. So it's basically an Arduino with Wi-Fi, Bluetooth connectivity, but also a screen, which is interesting for me, and 3 buttons. So I've already ticked most of my hardware requirements just with that. The only hardware requirements I don't have with the basic development kit is the 4G connectivity. Fortunately, as the M5 stack is composed of a lot of modules you can buy and just clip on the basic core kit, and they have some GSM, NB-IoT, and LTE modules. I will just have to buy one of these modules and to add them, to stack them to the M5 stack, and then I will have a fully autonomous device with battery inside, with a screen, with internet connectivity, with buttons. So with this, I will fit all the bill I have for this project. So here is a few tips of how I think about picking the right IoT hardware and the kind of range of connectivities you may need for your IoT project and the different solutions available on the market. I've ordered an M5 stack kit, so I'm really waiting for receiving this kit and starting programming with it. But the fact is, with the IoT, you can definitely start building your project without having the real hardware. So during the next video, we will do some architecture first, because I will need to have backend. I will host it on the cloud on Azure. I will need the front end, so all the people in the family can send pictures to my grandmother. So we will see how we can do this. And also we need some pricing evaluations before I go to production. So before these holiday seasons, I will need to know about how much it will cost to me. So I will need to do some calculations around the hardware I will use, around the connectivity, and also around all the services I will deploy to the cloud. So we will see in the next videos how we can do that kind of calculations and approximations to have a better idea before starting your project. Thanks for watching. I really encourage you, if you like the video, to like it on YouTube, or even better, to subscribe to the channel so you will know when I will publish the next video. And do not hesitate also to follow me on Twitter @Nanou, and also to add some comments to the video if you have any questions, or if you want me to show you something else in the next video. Thanks for watching, and see you very soon on Cafe Dev.